Okay, this video is going to be about solar resource analysis. I'm going to start with showing you a picture of the wind resource analysis. Now, what I'm going to do in this video is I'm going to this kind of illustrates in just a minute. We're going to talk about this. This illustrates really something for me about future energy policy. This video is about solar, though. Now, I want to tell you something before I start the video, just in case anybody thinks I am an expert at absolutely anything. They're full of complete crap. I'm not an expert at anything. I don't charge you for videos. So when I get a very amusing comment from Rathon, seriously, this lecture was a torture. Seems like you too are a student who knows only a little. That is absolutely true. What a wonderful comment. Wonderful comment. I am really a student. I don't claim that I know anything. So in this video, I am certainly not an expert at solar panels. I have to admit something. I have a little flat somewhere, and it does not have solar panels on its roof. So I am not an expert. Okay? But let's talk about this wind for just a second, because all you do, so you saw where I got it from, I hope. Oh no, I gotta go back twice. So, oh no, shoot. So I put these little links here, okay? It's just you can Google World Wind Map and get it, but here's the real thing. Now, if you look around the globe, there are a few places. All the wind is offshore, obviously, and there are a few places in Argentina you can get some really good wind. In Kenya, this is just this minute. In Kenya, there are some really windy places. In Morocco, okay, I don't know where else. But look at onshore. It's hard to get good wind onshore. I don't know, there might be a little bit of a typhoon. If we go to Northern Europe, it's all offshore. That's why when Dong Energy said that they could build an offshore wind farm and compete with, do that at a merchant price in Europe, it's a dramatic event. And you can see that this is this famous kind, it doesn't go down through Texas now, but this is this famous kind of wind, whatever, Tornado Alley or something like that. But it's nothing. None of this is anything compared to offshore. If we're serious about renewables, one day it looks like offshore wind kind of is the maybe an interesting thing to think about. Okay, so now I'm gonna go to my website again, and let's go to solar. And what I'm gonna do now is, I told you this is about solar resource analysis. I told you, like that man said, I am a student. I'm not anything else in these videos. In case you don't want to watch them, you know you can turn them off. Okay? So what I'm going to show you is there's this new thing. This video is going to be a lot about just using read PDF to Excel that I fixed a little bit. Okay? There's a new, I think that EU, it is just such a present. I was just so amazed. I kind of just clicked on the old website, and then I'm going to look in Cancun, because my friend is, because I like Mexico, and my friend was going to, I think that's Cancun is somewhere around here. And this, I want to show you kind of what you can do with this and help you perhaps interpret just a little bit some of these these results you get. And we're going to compare, just because he gave me some PVsyst and some Helios, I think, data. We're going to compare kind of results that we get from different sources. And I'm going to kind of go through some of these things at first. So if you click on this thing that says grid connected, it said, well, let's put a 1 kilowatt peak system in, and we can put 14% system loss, but that's an enormous number. We need to understand where that comes from. That's kind of the theme of this. So I'm going to optimize the slope, and I can't say that word, I'm sorry, and then we can visualize results. Now, if you visualize the results, it gives you, oh, wow, look at that. It's kind of like the whole thing. It almost looks like PVsyst, and it gives you the key thing here. It kind of doesn't say the capacity factor. It says the energy production on an annual basis is 1,500 kilowatt hours, which is divided by 1, so we get kWh to kWp, and you take that 1,500 hours and divide that by 8,760, and you get a capacity factor of 17.1%. Okay? Now, okay, just to introduce this, I happen to have this PVsyst open, and I hope I'm not going to get in trouble for showing this, but we in PVsyst down here, this is for a system. I'll find the size of the system in a minute. I'm just going to copy. This is how many megawatt hours we send to the grid. Now, I've got a whole bunch of crap open. Okay, and then we MWH, and then over here we put our size of the system, which is this 9,400 kWp. All right. This might be a long video. I'm not going to sit here and worry about that. If it's torture, I'm sorry. Just turn it off, please. This is kWp. That's defined as at something called STC, Standard Testing Conditions. And the big two numbers about standard testing conditions are 25 degrees Celsius. I can't spell it maybe, and 1,000 with a kind of light switch, kWh, weight W per m squared. That's how they test it. And then they see how many kilowatts you get, and then you add a bunch of them. So if we do this, we can take this kilowatt hours multiplied by 1,000. I guess that's kind of silly. And then we can say, well, the kilowatt hours divided by the kilowatt peak are this many hours, and you divide that by 8,760, and that's kind of how many full load hours you get. And that's 18.9%, which is higher. Of course, it might be just that 14% loss that went into it. Okay, and then I'm not finished. Oh, there's our beautiful graph. But I think over here's what I did. Now, oh, good. Okay. Well, all right, you don't care about Mao. Let's put my website. Okay, just to get the another site. Okay, so I guess you go to the solar, and we'll now get the one that says this is the one created by the U.S. There seems to be a little competition between the EU and and the US on this, okay? And so it says to get started, oh no, I should press, let's put an address, let's put Cancun. Let's see if it can find it now. This one, it doesn't find it. Searching for weather, oh, it just found something 160 miles away, not so good. Put it on a map here, maybe I can, there doesn't seem to be much else around here, okay. Okay, I tried a new location, let's see. I guess it won't get it. Okay, whatever. Then we go to the system information. Oops, I'm sorry. Come on. I'm going to make it a 1 kilowatt system like the other one was. Okay, and then it gives you the results, and you can get to the, I guess it goes, and it kind of gives you all the stuff here. This time it's 16.7%. So we have 16.7, 17, and 18% capacity factor. And that's what we'll talk about. Now I'm gonna show you one more. Now if you go to the Google Drive, if you go back to Chapter 5, which is electricity, and then I have conventional electricity and renewable electricity. That's where I collect some of the stuff. And if you go to this thing that says resource studies, you can go to solar resource studies, and then I have a few. So here is our fourth data point. They had KWH to KWP. So as soon as you see that, that's fine if you're used to that number. Or you can take that number and divide by 8760, get the capacity factor, take the capacity factor, multiply that by this number. So 1433.7. That's the only thing we need to know. That's the key number, 1433.7. And then we take that number and divide it by 8760, and now we have 16%. So we had 16%, 18, almost 19%, and that difference. And then I think the lowest, no, I'm so nervous about this, whatever his name was. He's going to say, I'm a student. Yes, I am. Okay, that 16.7%, so it's actually, this one's about the same. 16.3 was kind of the lowest. And we take this one divided by this one, and we get about a 15% difference. How does that occur? And I want to start, I want to show you now. I'm just opening our generic macros because I'm, okay. How do we get a 15.72% difference? Now I'm going to start with the EU one, because that was the coolest one, really. That really was so neat. Okay, and okay. Okay, so we're back to Cancun, and we're back to the EU site. And I'm going to go one by one through this and show you how you can kind of practically do this as quickly as possible. This is what we did already. This 14%, I think, was a little bit arbitrary. We need to talk about that. Now, you could download the file. And when you do that, sometimes, shoot, this happens. Great. Okay, how about we'll download it and then just save the file. And then once we saved it, we better go and open it, okay? All right, you can see I've saved a few of these before, okay? Now, if you do this, it puts the, see those later. It puts this is month 1, and if it put 01 here, it would be fine. Then we could go to data. So if here, so we cannot do this. We could do it in 2 sections. We'd have to make it kind of go up to 9, and then go to data and text to columns, and okay, 1 column. Sorry about that, but we'd have to do it there, and we'd have to somehow do it there. Yeah, it would be a pain. Sorry. So what we could do is go to the thing and click on this visualize results one, and you get the PDF file. How about we just open this file? We don't have to bother saving it. And if we want this data, we'll get this data. Excuse me. I hope that doesn't mean I'm torturing you. Okay, and then as long as you have a file named read PDF to Excel open, and you can get these about 1,000 different files, I'm sure. Okay, you just open that. I happen to have it always close at hand. Oh, God. And then, come on. Just a minute, I need to put. Okay, you just open this read PDF. It says Shift-Control-A on the bottom. You just press Shift-Control-A, and most of the time you just click the green button, and then you have it. And then if you press Shift-Control-U, it does the little thing where it puts the month. Now, this standard deviation is kind of I'm going to talk about that a little bit later. That's how you could try to get P90 and P50 and all that. If you press alternate equal, this is this thing that we just looked at, and this is the if HM, let's just see what HM was. HM is the 2010. That's the yearly in-plane radiation. I'm a student of this. 2006, and it said it was 2010. I'm not sure the small difference, what that is. I should know because, I'm supposed to be an expert at things I make videos on, but I'm going to stop and say that, well, that's kind of the radiation we're getting, and so this is our for a 1 megawatt plant, and we can put our capacity factor, okay, and divide that by 8,760. Shift-Control P. I don't have my generic macros open either. Oh no. Okay, and then those are the 2 files, and I might use another one in a minute. Control R, and then the performance ratio could be computed as this final one divided by that one. That wasn't the fault of generic macros, so they have a kind of a 74% instead of an 81%. And if we go back to look at our the PV, now I'm going back to the PV syst. They have a nice little table, and perhaps it's a little bit more clear now. I'm going to do the same thing. I'm going to take this table, okay, and copy this table, and we'll kind of put it right next to our file we just made. Okay, and Shift-Control-A again, and we better reset the column number just in case. I guess you didn't really have to. And we can use, hopefully, the Shift-Control-U again. And the Shift-Control-U Okay, and it didn't get everything exactly right. Well, it was pretty close. Okay, all it does is, that's a simple one. Whenever there's a space, it just puts it in. Now this is where we have the performance ratio was, why don't I, on this one, press alternate equal. Oops, that didn't work. Okay, so perhaps I better press this, alt equal, alt equal, I put it up below, didn't it? Okay, and shift control R. And the performance ratio should be, on this one we needed the capacity, remember? So I need to open this one. Just a minute. So I put the capacity in. And then we have, this is our global effective shift control 7 radiation, okay? And we can take the kind of capacity factor for the year divided by this number, oops, and I was wrong, that you take the final capacity factor after everything, and you get, so that the performance ratio, this performance ratio is defined here as the, I had this wrong, it's this column, you can't kind of undo easily that stupid thing, it's how much radiation we have at our inclined plane. You can take the capacity factor, and then you can take your final one, and we have the performance ratio. Now, if we looked at this one, we have two problems. Comparison. Get it out. You're just a student. This performance ratio. So we have two differences. Our radiation is a little bit lower, and our performance ratio is lower. That's why we're getting the almost 19% versus 17%. Okay, and let's do one more. Let's put. I notice I put EU. I'm going to call that other one US. The one. Just a minute. Okay, this PVwatts allows you to get monthly or hourly data. We'll get back to that in a minute. If we get the monthly data, let's compare now. Oh, shoot! Oh, no. Okay, it took me a little while, but I'm back. And here is the thing from the NREL one. And hopefully we have this one. So we have, oh no, I swear, this is when we read the data, EU data, we had some problems, and then we read it from the PDF. This is the EU summary, and then we read the PV system, and this was really PV syst. Okay, now let's compare, do another little comparison. This was a 1 kilowatt system. So right now we can put in, we can see what the performance ratio is and the capacity factor. I'm just used to using this because this is the percentage of the time that you get the sunlight. This is the percentage of the time you get sunlight at. I should have really been explaining this. What a horrible student I am. I should have been saying, well, this is the time. Oh, no. This is the time because this really, really important point. STC, the capacity, is defined as 1,000 watts per meter squared at any instant. So now the EU had a 17%. If we just get the percentage of the time we get, this says if we had 1,000 watts every single hour, we would get 100% capacity in the nighttime and the daytime and everything else. Okay, and then we can copy it over to this amount we get at the plane. Now, this is 22.00000. This is 22.9, not so different. PV cyst was 23.28, a little bit different. So we're getting a little bit difference here, and then we're finally putting this to the grid, so our performance ratio is this divided by this. Okay, enough of the performance ratio. All right, now, probably because they made the same assumptions about 14% losses, and I think I think the next thing I'm going to do is go through. Okay, so now I'm going to go through one by one. We've done the grid connected. And by the way, if you switch this to a thin film, what happens is nothing. It keeps the system loss the same, essentially, and if you click on these optimization things and you go down and visualize results, the difference in the output is no different. There's no difference in the output. And that's because the losses are the same, and that's because the losses don't carefully account for a temperature coefficient that's going to be a part of this video. Perhaps I'll have to make it part 2 of this video. I think this is going to have to be a 2-part video. So let's go and just finish this wonderful EU program where we look at the European Union flag. I like that. Okay, and let's go down to tracking. Now, the interesting thing about tracking is just how much does it really help. Okay, and you press, we can optimize the slope. So we're going to get all of these things. Now, with all of these, if you download, except the hourly data, if you download to the CSV file, here's what happens. You get the problem with month 10, October, November, November, December. You get those 3-month problems, and all the things are out of order, and you can't just do a text to columns very easy. Maybe there's some other way, whatever. But it's not completely obvious. So you can go down and hit the one that says visualize results again, and you get this wonderful little thing that shows how much we get with different, either a vertical axis or an inclined axis or 2-axis tracking systems. And then you click on PDF, and then it downloads it. And this is the umpteenth time I've tried this. Now, what we're going to try to do again is just read this PDF straight into Excel. And it says this is the vertical axis, and it gives you EM, HM, and SD again. And it has a vertical axis, inclined axis. And the EM is, as before, EM is the average monthly electricity production in kWh. HM is the average of the irradiation. And you can see they're kind of similar results because this is a 1 kWp unit. Okay? So after we download it, let me make it smaller again. So we go to the read the PDF file. And this was it. Okay? And when you read the PDF file, here's the pain. You select this, and it never takes the month names. Oh, I hate that. You can kind of start up here and can you get the months? Then you can kind of get the month's names in here, month names, Control C, and then throw that into our Excel file, which I called Solar Yield Analysis, and you press Paste Special as Unicode text, and it gives you one of these horrible things. And I've said before, I've been working on this a lot, and now I think we can fix it. You press Shift Control A, and then instead of reading the top one with the Read PDF Open, you go to the second one and you press this one that says Input Rows, and then you can adjust this, but these were month by month. So there are going to be 12 rows, and then it's going to go down to 12, make a new row, go down to 12, make a new row, blah, blah, blah. So you can do it with different numbers of rows. And then it gives us, okay, it all worked except one little thing, and that's the very first one. And in my spirit of not letting the perfect interfere with the good, l'ennemi de le mieux. We don't want to do that. Now, how about Control C, Alt E, S, E, I guess, is that right? Okay, and then we can now shift down, Control minus, and we have all of our vertical axis, and I'm not going to bother putting the EM, HM, and SD here even. And then we can go and get our total for the year. Okay, and just sum this. Now, you might say, oh, the EU doesn't get this right. If you could press Control D, that works. And then C, okay, so we have all of these. So the difference between this wasn't a great deal if we just do it in a kind of, this was a 1% increase, and this one, this 2-axis tracking versus the other one was a 3%, so I guess that's a little bit more. Now, remember what we do, this is in kWh of production. And if we want kWh divided by kWp, we put 1. But if you want it in hours, then you divide this by 8,760. That gets our capacity factor, Shift Control P. And this was in kWh per meter squared. And remember that you compare to the 1,000 meters squared, so it's really the same unit. These capacity factors are the same. And here's what's so interesting about this, is that when we put all our tracking system together and press Control X, and we go to our comparison, which is this EU summary, that's what we did without the tracking. Okay, so I just moved it. Without the tracking system, we get a capacity factor of 17%. We get the kind of the output, the percentage of the hours output, the capacity factor of 22%, and then we put this actual output to get our performance ratio, which is here. Okay, now the big deal is that this 17% becomes 22%. So the tracking adds a lot. And if it adds, here it adds 32%, 33% to the output. And if the cost is a lot less than 33%, it certainly seems like a good thing to do. The banks might not like it too much because they hate anything that's mechanical and risky, but these are just too good to let go, if that's really the case. In this one, in terms of our final output, we get an increase in output of almost 40%. I don't know why this thing is, I'm sure somebody knows, and I'm just a student, remember? So, and then we can do the same thing on the final output. And then it's about the same thing, and we can do the same, compute our performance ratio here, okay? This is our, excuse me, this divided by this, that's our PR ratio, 75%. Okay, so that's the next thing that they give you in this EU thing. Maybe you can, I think you can probably get something like that out of this PVwatts, but it seemed to be clearer here. Okay, and then let's go back, and then after we put this, I'm going to skip the off-grid. The monthly data is not that much, but you can get it for multiple years. And now I'm going to question this whole business of standard deviation that they're talking about. They put the standard deviation in. We can get it by all of these things. And then if we do the same thing, I think, let's get all these ratios, just about anything. Now, if you do it, if you put it into Excel, it's a mess. Because it puts everything, and separating it all out is not so easy because they're not in a consistent row. So let's visualize the results once again. And then it kind of makes a nice little graph with horizontal radiation, optimal angle irradiation, and it goes month by month, and you can kind of see the variation. And that's what this standard deviation business is all about. And I don't know how many times I've talked in terms of standard deviation relative to the P90 and the P50 and all of this business. Okay, now we're going to do the same thing. Let's read the PDF file. Okay, save it, open it, and then we've got some of this data. Okay, and then once again, we read the data in, and this is global horizontal radiation. Let's get the one that says global irradiation at the optimal angle. All right, and let's put this in and talk about read PDF again. Sorry if this is like a torture to get through. Probably is. This paste special is Unicode text. And now we have these years in the middle. That creates even worse of a kind of mess. Okay, and what we can do then is Shift Control A once again, and I modified this so if you don't have this, or if you have an old version, you've got to re-download it. And even if you got the Google Drive, I didn't put it on the Google Drive yet. That's going to be in a little bit. But this says break with the years, so we don't click on this. We break with years, and then when you put the break with years, it looks for like 2000, anything that looks like a year. I think from 1980 to 2025, I did something like that. It's you got to be a little careful. ESE. Okay, and okay, we got this done, and now we can get our radiation by a month, and we've got it from 2005, and we can get the total for the year. Can I press Alt equal there? Yeah, I can press Alt equal. Or can I? I'm doing exactly what our friend said. Oops, that didn't work. Alt equal, excuse me for my Excel. Okay, and let's copy it down. Okay, total for the year. And here's what I don't really understand. Why did I do that? And here's what I don't understand. This is global irradiation. I'm so nervous about all these people complaining. Then, if we compute STD, which is what the banks really would care about, a little bit of month-to-month variation is not that big, but I'm going to compute the standard deviation of this, and I get a standard deviation of 43, which is in terms of kilowatt hours per meter squared, I'm sure this is. Okay, so we could over here, again, as usual, divide it by 8760 and get our capacity factor by year, which is kind of our gross capacity factor. And then we get our standard deviation compared to the average is tiny. And then we put the average. Okay, so here we get that, and then here our standard deviation by the average is only 2%. Now I don't know what the EU really reported in all those standard deviation numbers, but that 2% leads to a, if you wanted to put a P90 on the capacity factor, then we put equal NORM INV, and it asks for the probability. So let's put 0.1 for P90, and let's put the average, and then the average, and then the standard deviation, and you get a P90 of 20% versus a P50 of 22%. So you can see that, which I suppose this divided by this is 88%. We need that kind of DSCR. We could then go and say, well, if this is a decline of 88%, we do our famous DSCR requirement, which says, you have to watch another video for that. It's equal 1 divided by, I think, 1 plus this thing. I did it backwards. Excuse me. Well, it's about 20%. I'm gonna do that later. Excuse me for that. Oh my God. Oh, this is tedious. Okay, so let's go continue. Let's just finish this. When I'm finished this, I'm finishing the video. Okay, let's go to the next one they have in this wonderful thing. Okay, and the next one they have is daily data. And you can get the clear sky irradiation, or the on-sun tracking plane. Oh, no, let's get I don't care about clear sky. I want the kind of total. And I guess this time you got to get it for 1 month, so this doesn't do nearly as much. And they'll give you a temperature profile. So let's take a kind of a bad month and let's visualize the results again. And this time it kind of shows you, global, this one, diffuse, direct. How much is hitting the whatever. And then we can download this again. And now if you want this one, okay, for some reason, don't tell me why, when you copy this stuff into the PDF, you get it in the old method. And Shift Control A, and then we do this top one, and it kind of should put it there for us, okay? I don't know, the time maybe it tried to compute that as a time, but then you can get this graph. That for me is just not very big a deal. This one, I'm gonna Alt-EL this and Alt-EL this one, but again, that's more of a PDF issue, read PDF issues than anything else. Okay, just 1 second. Shoot. So, excuse me, I had to put this back in. So if the percent reduction is DSCR minus 1 divided by DSCR, if you don't know that, watch about 20 of my videos. then you take this and move it around and get DSCR is 1 divided by 1 minus the percent reduction. And I needed to switch this 88% into the percent reduction. So the DSCR from P90 is 1.14. That's what it's saying, which is an interesting kind of thing. Okay, now let's go back and, sorry about kind of going back and forth again. Then let's, now I'm starting to apologize, oh God. And let's do the hourly data. This typical year, month, I don't know. You can select some kind of periods, but let's get the hourly data. Now, I'm afraid of Excel crashing, and I'm just going to tell you, I got the hourly data before, okay? And it gives us PV power by hour. It gives us the radiation components, okay? And we can even get it on a vertical inclined plane or a fixed axis or anything like that. Okay, and we can put the optimal slope in and all that stuff. Then when you get this, now I'm terrified of this because sometimes my Excel crashes, and so does other people, because I tried this in a class. Okay, you go to the, you go to the, where you downloaded it, okay? And I've got to go and get it. Excuse me, okay. And it has a time series. And this time series is just an, oh shoot. Okay. Now the time series, sorry, it did crash. But it gives you a 6 megabyte, not megawatt, 6 megawatt file, where our other one was only 31 kilobytes. But let's kind of see what we can do with this one. So the nice thing about this is that we can, and this is the, okay, here's a little bit of a restart. I hope I can edit this stuff. So here's the file it gives you after you struggle, and the first thing let's do is press F12 and save it as a workbook, okay? And then this file is a really big file. It's about a 6 megabyte file, just in case I didn't edit that out. Now, to make an analysis with this, we can take these things and, unfortunately, the EV and the BIL, remember what they are. This is the temperature, and we'll get our kind of what these things are at the very bottom. Okay, let's move these to the top. And then we'll finish our analysis in just a minute. But I want to show you now the magic, really, of, so this is, how about we'll put our titles in a little bit better. This is our PV of our system power. This is our imbalance, okay, all of these things. And I have probably done this before. I love to do this kind of stuff, is use, match, and index and start graphing things. But if we just graph a few, let's just graph our system power. So if we go down a few different lines, we can press F11 and it'll give us kind of when we had some clouds and what this really looks like over time. And okay, and then we can also put this, let's get it by, we can, as soon as we get the data like this, it's going to be perhaps a little bit repetitive with getting the other monthly data, but we could get the year and the month and the day. And all we have to do to get the year is put left and click on this and put 4, but then you better also go around that and put value. okay? And then you can get the month and put mid and start with 5 and put 2. And you, oops, MID, okay? And then you better put the value around that, okay? And then we put mid and go to this text and put 7 and put 2 and put a value around this. Now to get the hours, you could also do the hours kind of going backwards, but I'm going to do it how I think when you have a little bit of an electricity analysis. What I do is I just count from 1 to 24, and so let's just count the hours. And then as soon as if this one, the prior one, is equal to 24, then we recount. If this one equals 24, then we start 1. Otherwise, we take this plus 1. Okay? So let's just first double click and get the whole thing. Then we can get the hour of the day. And so if we wanted the average, and there's something wrong, because clearly, well, I'm not going to comment on this. I can't say this is what I was worried about. This doesn't start till, hour 14, 2 in the afternoon. Okay, so there's something wrong. But here's what, let's just do some basic. So if I put 2005, Alt-EIS, click on a column, you can press tab and click on 2015, I think is the next one. Then if I put average if, then we can click on the detailed year, then the individual year, and then we can get our solar production. And this gives us the average. Oops. Huh. I'm perhaps in formulas and automatic, just a minute. Oh, shoot. So now we have the average hourly production. Kind of cheated just a minute because I didn't have all the years there. Excuse me. I had to, and when I had downloaded this the last time, I should have put in 2015. Okay? Excuse me, I think. I messed up. And then we'll, so now we put now we've got the average production per hour, or this is actually the average EV, the system power in not in kilowatts, in watts. So in kilowatts we would have, or our capacity factor for the average capacity would just be this divided by 1,000, because we have one kilowatt system. I don't have generic macros open. So then we have the same kind of thing, and we can do all sorts of things, average by hour and all that. And the same thing, if I put an average, here's our capacity factor, standard deviation, of the capacity factor, and standard deviation divided by average is only 1.8%. I don't know why it's not exactly the same as the other one. I could think about it, but you get the same sort of result, and that's what you can do, and then compute our P50s, P90s, and all that. So this EU thing is really pretty nifty. Now I'm going to make a second video that kind of goes through the temperature coefficient and perhaps what you should do instead of putting that arbitrary 14% losses, and if there's any easy way to do this without doing any really kind of detailed engineering. And it's going to show that, of course, it's going to show that the biggest factor is the out of all those losses, out of all the performance ratio, the biggest factor is the temperature loss. We'll look at PVsys and other things to show you that. And then come up with some crude methods to kind of do it. So here's my tedious video. It's a very long video, and I hope you haven't watched the whole thing. Oh, wow.